Hello everyone, my name is Jonnadula Sahith, and we as a team have been working together on a major project under the guidance of Y.Nagendar. The project is titled Smart Waste Classification using OCR. So we have worked on this project over the course of 12 weeks. We have actually chosen this project due to various reasons. The main reason being the increase in globalization as well as urbanization, which leads to a lot of waste production across the globe. So the major issue with this is that we have a lot of waste that's being produced, and the current waste classification techniques aren't able to keep up with the waste that's being produced and are unable to classify them accurately. The main issue relies on is that the most of the waste management and classification techniques will use humans or use outdated techniques which might not lead to a proper classification method. So we as a team have actually came up or tried to come up with a solution that is going to be much more efficient than compared to existing solutions. We are leveraging the use of OCR as well as other machine learning techniques, which will help in efficient as well as better accuracy when coming to the classification categories. Hope we also have made a presentation in which we discuss about how this waste classification and how our project will work as a whole, and I hope that you look forward to that. Hello, welcome to the presentation. And as mentioned beforehand, our project is small waste classification using OCR. I am Jonnadula Sahith, bearing all ticket number of 210385117, and as listed here, these are my remaining team members. And we have done this project under the guidance of Y.Nagendar sir. And going forward, the introduction, as I further already explained, this project is going to be aiming to developing a smart waste classification system that can classify waste accurately with the help of OCR and machine learning techniques. So the approach that we came up to with this is by combining a hybrid model or making a hybrid model which leverages both optical character recognition, which uses textual and pattern data extraction, and transfer learning for feature extraction. OCR is going to be capturing any textual data, which will help in the classification process, while transfer learning will help keep track of the features that will help in the classification process. After that is the problem statement. Due to the globalization and urbanization of the world at a rapid pace, the amount of waste that has been generated has increased substantially. So efficient waste management is also hindered by improper waste segregation leading to environmental pollution and recycling challenges. The traditional methods struggle to keep up with this process because there's human error and, of course, classification errors which are going to be happening. So the main goal is to create a system that can automatically classify the waste from images with high accuracy, leveraging various machine learning models and OCR or like problems in texture, distortion, patterns, and diverse backgrounds. The solution is we design the hybrid model consists of two key components. The first component being the OCR, which is optical character recognition model, which extracts the textual information from the pictures which are present to enhance the picture representation. We will also doing Keras plus transfer learning models, which leverages trained models to extract the spatial figures efficiently. And we have to do data augmentation because every image will not be present in the same way. So we have to apply augmentation like rotation, zoom, and flip so that we can make all of the images more accurate. And going over the project architecture, we are going to be getting the waste from the waste management authorities, which almost collect all the waste. We're sending it to an image capture module, which is going to be capturing all the images, which is going to be getting stored in a cloud or a SUMS database. From that, the OCR node is going to be testing and do the plastic identification and see if there's any textual information on it. If there's any specific symbols which are found, we are going to be sending that information to the separating mechanism, which in turn will classify the waste if that information is enough. And if there's no symbols found or any important textual information, then we are going to be sending it to the model processing node, which is going to be having pre-trained models, or which we have trained beforehand, and going to be implementing the use of transfer learning in order to understand which features are necessary. And we are going to be obtaining an SS result with the help of the information we got from the OCR module as well as the model processing node, which is implemented by using transfer learning. We are going to be doing the classification process. Going forward, the data collection, we have used the dataset of EcoSort waste dataset, which is sourced from Kaggle, of course, and which contains image categories in different types of waste, like biological, battery, etc. The data preprocessing is done with the help of data augmentation, as well as maintaining a fixed dimensions. The model, of course, already mentioned, is going to be using OCR as well as transfer learning. Going forward, the training process is going to be split into the train as well as the test data, we need to ensure that the preprocessed waste classification dataset is using a custom data generator to efficiently load and process images. The training also includes early stopping, so make sure that if there's no loss which is going to be present, we can stop the training early in order to actually make the model run more efficiently. We have modeling checkpoints in order to prevent overfitting, and also learning rate reduction, dynamically reduce the learning rate when validation loss stagnates, improving convergence. We also have done a literature review on various papers, which have been actually looking into the same problem, and I've been actually trying to solve the same problem. And we have done a literature review on like around 8 papers, and I have got like around 4 papers here for reference. We have also tested various different models like CNN, Resonant 50, VGG16, MobileNet V2, transfer learning, and many more. The dataset, if you go further into the dataset, the dataset consists of 20,000 or so images, which have various categories like clothes, shoes, paper, biological, and battery, cardboard, plastic, white glass, and metal, and more trash. So pre-processing, as Biff mentioned, each image has to be resized and augmented properly through rotation, flip, etc., so that we can achieve all the information required for classification, because the textual information will not be present on one side, it can be present on every side. We have spread the dataset into an 8515, which is consisting of the trained dataset having 20,564 and the test dataset having 2,513. That's an around average of how this splitting has functioned. Going forward, we have the various evaluation metrics, which we have used in order to check with our model. The accuracy is the ratio of the total corrected predicted instances to the total instances. We have also checked with precision, recall, and F1 score. F1 score being the harmonic mean of the precision and recall, combining the bias between the two. And recall is how many did the model correctly identify, whereas precision is of all the items the model predicted of a certain class, how many were actually correct. And going for the future scope, we want to improve the accuracy further, even though we have currently gotten a 90% or 93% accuracy. We also want to further improve the accuracy so that it becomes more accurate and doesn't bring any issues coming to the classification process. Real-time processing, optimizing the speed and efficiency of the model so the model inference is faster and resource consumption is minimized. Scalability for industrial use, by improving the processing speed and the model robustness, we can make it so that it efficiently can be used in a larger scale for operations. Multi-language report, focusing on language record so the OCR model can work on other languages as well, because most of the textual information is will be present in English, but in some cases, if the textual information is not present in English, it also has to understand that and work further. And going forward, the conclusion is that we have developed a deep learning-based waste classification system using OCR and transfer learning, achieving a high accuracy in identifying and categorizing waste. The key takeaways is combining OCR and transfer learning enhances waste identification, data augmentation, and pre-trained models, improving model generalization, performance, and efficiency, and automating the waste segregation significantly reduce the landfill waste and promote the recycling. And that's pretty much it. Thank you for actually watching, and that's all.